Welcome to this video on gradient boosting regression. Today, we'll walk through how this powerful algorithm works on a small dataset, step by step. Let's start with our small dataset. It has 2 features and 1 target variable with 5 samples. Our goal is to predict the target values based on the features. Gradient boosting is an ensemble technique that combines multiple weak learners, typically decision trees, to create a powerful predictive model. The key idea is to train models sequentially, with each new model focusing on correcting the errors of previous models. Let's walk through the gradient boosting process step by step. Step 1. Initialize the model with a simple prediction. For regression, this is typically the mean of the target values. For our dataset, the mean target value is 10.96, so all our initial predictions will be this constant value. Step 2. Calculate the residuals for each sample. The residual is the difference between the actual target value and our prediction. For example, the residual for the first sample is 10.5 minus 11.16, which equals negative 0.66. Here are all the residuals for our samples. Step 3. Train a weak learner to predict these residuals. In gradient boosting, we typically use simple decision trees. For demonstration, we'll use a tree with a maximum depth of 2. Here's what our first decision tree might look like based on our features and residuals. Step 4. Update our predictions by adding the predictions from our weak learner. In gradient boosting, we typically use a learning rate to control how much we adjust our predictions. Let's use a learning rate of 0.1 for this example. We update our predictions using this formula. Here are our updated predictions after the first iteration. Step 5. Calculate new residuals based on our updated predictions. The new residuals are the difference between the actual target values and our updated predictions. These new residuals will typically be smaller than the original ones, as our model has started to learn the patterns in the data. Step 6. Train another weak learner on these new residuals. We repeat the process, fitting a new decision tree to predict the updated residuals. Here's what our second decision tree might look like. Step 7. Continue this iterative process. We update our predictions again using the second tree, calculate new residuals, train a third tree, and so on. This process continues for a predefined number of iterations or until the residuals are sufficiently small. Why does gradient boosting work so well? There are several key reasons. First, it focuses on correcting mistakes. Each new tree specifically targets the errors made by the combined previous trees. Second, the learning rate prevents overfitting by making small, careful adjustments at each step. Third, by using multiple simple models, it can capture complex patterns in the data without requiring a single complex model. Finally, gradient boosting is versatile and can work with various loss functions for different types of problems. To summarize, gradient boosting regression works by first, initializing predictions with a simple model, then calculating residuals, training weak learners on these residuals, updating predictions with a controlled learning rate, and iterating this process multiple times. The result is a powerful ensemble model that often outperforms other machine learning techniques for structured data problems. Thanks for watching this step-by-step explanation of gradient boosting regression. I hope this has helped you understand how this algorithm works and why it's so effective for many prediction tasks.